the past in examples like this. Recall, I could have said, what is the solution? Graph the solution. For x. So you've seen equations like this before, haven't you? Where to graph this, what was your objective? To get what by itself? It's a variable, in this case x, okay? Because back in the day, you only had x, you didn't have x and y, or you would have had, just one letter. To do that, you would subtract on both sides. Now remember, when we saw these inequalities, we treated this stuff just like regular equations, except for when. When did a red flag go up with these? When you multiplied by a negative or divided by a negative, right? So the only red flag is if you multiplied or divided by a negative. What happened? The sign did what? Sign changes or flips, however you like to think about it. So that was a big deal thing that we had to practice doing back in the other chapter. Now, in this example we're remembering here that I've just set up for you, it's pretty easy. You subtract 5 from both sides. There was no multiplying or dividing. So your sign stayed the same and you just copied it down. And in fact, here you have x less than 5. You read it like a book left to right. X less than 5, right? To graph it, you can make a number line. Let's see, 0, 1, 2, 3, 4, 5. So if it's less than 5, it's going to be open, not including, and going to the left, right? Okay. So x less than 5. And some of you guys may have done a parenthesis. That's fine too. Something to symbolize not there, not exactly equal to, but below the 5. So here's the deal. We're going to add a dimension to this. We're going to add, the 2 axes. That's what we did. We took our number line, remember? When we first started lines, we took our number line, and we said, let's have 2 number lines. We'll call one x and call one y, and now we can talk about the relationship between 2 different variables. That's what we're doing here. We're still going to be coloring, just like always, but we'll have to be, conscious of an x and a y. So that's why we had to learn how to graph lines first. In fact, let's remember that, because these are the building blocks for what we're about to put together. Let's recall how to graph a regular line. Y equals, and we'll use our quiz problem. Y equals negative 1/3 x. And what was the intercept on that? Let's see. Minus 1. If you had to graph this one, we learned that when you have 2 letters, you like y equals mx plus b, right? We learned how to deal with x and y both that way, saying that the b is what you start with, right? And where is the b? The y-intercept is where it crosses the y-axis. And which letter on here is it? The negative 1. So graphing a regular line, remember, where we have the 2 number lines intersected, the x1 and the y1, we would go to negative 1, put a dot, right? Then we would get the slope. The slope is what's attached to x, negative 1/3. Slope is rise over run, right? So the rise is up and down. Is this telling me to go up or down 1? Down 1 and to the right 3. So I always start at negative 1. I start at that y-intercept. Then I say, okay, now go down 1 and then to the right 1, 2, 3. Something like that. I went down 1 and to the right 3. From my initial point. You only need those 2 points and then you can graph your line. Look at that, how horribly I missed that point. Nice bold one now. You get the point hopefully. Some line going through both those. These are the 2 biggest building blocks from your past that being comfortable handling are going to help you with today, basically. If you're good at graphing this by hand, if you were okay dealing with inequalities, it's going to be a day in the park. If not, guess what? You got to go back and learn. Go back and learn this so you won't be freaking out today, because math is cumulative. If you're not getting stuff from my past, you need to go to tutors before you come to class. You don't come to class saying, I don't understand. These are things we're hoping to bring to the table in this discussion. If not, get it before the test, okay? So that you're okay. But we remember how to deal with this, how to shade this inequality, and we remember how to graph a plain line. Now the only thing we're going to add, guys, are these symbols on top. Less than, greater than, less than, or equal, who cares? We're going to add them. We know that the only time they will flip will be when? Multiply or divide by a negative number, okay? And as far as the shading goes, we'll discuss that in a second, but we can at least graph the line and then talk about how to shade, because that won't change. To graph it, we'll get y by itself and draw that line. We may have to worry about shading at the end, though. In fact, we will. So let's put these two things together. Let's say I'm just going to start with graphing. Actually, I'll put them together in kind of a slow order because this is the easiest approach. Let's say I gave you something already solved for y. So you don't have to worry about the first part. You don't have to worry about your inequalities flipping. You're only getting an equation. Of course, remembering that if it was not solved, if it was not already y by itself, that's the first thing you would do, right, guys? Get y by itself, flip the sign if you have to, if you multiply or divide by a negative. I'll start you off with that already done. We'll focus on the graphing first, then we'll go back into that flippy stuff. So here's our equation. Remembering, of course, that we like stuff in this form, so we're pretty happy with what we've got here. This looks pretty similar to us, right? Talk to me, people. This 3, what am I going to do when I graph this? Okay, so go 3 on the y-axis, through the dot. What's my slope? M equals what? Okay, that means I'm going to go, okay, so from this point, 1, 2, 3, 4, 5, to the right 1, something like that. So nothing has changed so far. If I could graph a line before, I can still graph a line today. Get y by itself and use the y-intercept and that slope to graph it. There is something different, though. Normally it's y equals, isn't it? Y less than 5x plus 3. When you think less than, naturally, when you're looking at the picture, are you thinking on top of or below that line? Tell me what instinctively. Less than. Which one's less than, the top or bottom? Bottom. That's kind of what you think. Good, because you're right. Color below the line, and then you're done. Also, we should note that since it's less than, there's no equal to. Should it be a solid line or a dotted line? A dotted line. So I'll make that in red on top. Since it's just less than, we'll actually go ahead and be careful to show that it does not include the exact line. We'll put some dots here to say, hey, not included, and the less than is below. So the line itself is not actually included in our final answer. We're just going to use dots. And less than will always tell us to shade below. Below is an E. And it is how you would expect on the picture. The thing's slanted, shade up under it. That's the up underside, isn't it? It's really unfortunate because your graphing calculator does such a charming job of this. I really wish I had more time to do that with you. Maybe at the end of lab or something tonight, if you, depending on how you guys feel after break, I may teach you how to use your calculator to check yourself. Yeah, Chelsea. Well, you're not looking at positive and negative. You're looking at below it, below the line. So you would ignore it and you would say, okay, this is what I'm looking at. Something slanted like this. You don't care where it's at on the system. You just see the slant. That's the top. That's the bottom. You see what I'm saying? Good question, though. I can move this thing anywhere, and I'm just looking at what's on top of the line, what's on bottom of the line. No, I'm symbolizing, what my picture symbolizes here, just like on that number line that I drew for you earlier, is everything. In other words, 0, 0, guys, is that an answer for this graph? The point 0, 0? Is it in my shaded region? Sure. The shaded region represents the answer, doesn't it? Just like in an old number line. The part we color represents what the answer, what satisfies their relationship. So sure, 0, 0. What about when x is 0, y is 1? What about that point right there? 0, 1. Sure, that's in the shaded region. What about, I don't know, something over here on the top left? Any point up here? No. What about this point right here? At 0, 3. Yeah, it's on the line. We don't include the line, do we? Because it doesn't have the equal to symbol underneath our inequality symbol. So let's make some notes. Note the point, let's see, when x is 0, y is 3, is not a solution. My screen's messing up again. Other notes, if you pick something like 0, 0, that is a solution. And you guys are so lucky. In addition to having a graphing calculator, which if I can't teach you, you can learn it later. It's really fast. In addition to having technology that can help verify for you what's up, you can test this. You guys know how to test if an ordered pair is a solution. You learned it like way in the beginning of this chapter. Hey guys, 0, 3. Show me it's not a solution. What do you do algebraically? Plug it in the equation. You'll get a false statement, and you'll say, oh yeah, it's false. It's not a solution. Done. So you'll know. In fact, if you can't figure out where to shade, you could just pick a point. Pick a point below or on top, and it'll verify to you if that's a solution or not. You know what I'm saying? Like right here, the way we colored, we included 0, 0. When I plug that in, I better get what kind of a statement when I plug it into the equation? True or false? True. Okay. There's lots of connections here, aren't there? The less than being below the line, greater than being above the line, stuff that kind of makes sense. Connections as far as taking those points and plugging them into the original equation, that's a good connection to make. Because we can do that to double check what we're looking at pictorially. In the algebra, we can check our work, what we're seeing on the picture. I recommend you guys try that when you're working your problems, just to make sure. I can try it once if you want. You want me to try it with one of them? Look, let's check 0, 0. X, Y. I'm going to check this one with the group, just to teach you, make sure you're comfortable. So let's see, Y is 0, Y less than 5 times 0 plus 3. Doop-de-doop. 0 less than 3, is that true or false? True, good. We hoped it was true because we said it was an answer. That's how you check it. And the cool thing with these problems, guys, is if that one point worked in the region, you don't have